We begin the process at the afferent arteriole through which blood flows into the glomerulus. Substances like salt, nitrogenous wastes, vitamins, and glucose seep into the capillaries as we head toward the Bowman's capsule. Once we arrive at the proximal tubule, Na+ ions and chloride move into the interstitial fluid by active transport, with salt, amino acids, and glucose. The change in concentration triggers osmosis, and water diffuses into the peritubular capillary along with salt. Glucose, potassium, amino acids, and bicarbonate are also taken up again in the peritubular capillaries. Hydrogen and ammonia are let out by epithelium salts in the tubule, as well as toxins and drugs, in order to control filtrate pH, and urea is also absorbed by the tubule. As we travel down the loop of Henle, notice the aquaporin proteins forming periodic water channels through which water is reabsorbed. At this point in our journey, the filtrate is at peak concentration, allowing urea to diffuse into the medulla. Here, renin is released to regulate blood pressure. Now we go up the loop of Henle, and NaCl passes into the medulla through active transport, lowering the filtrate's concentration. Aldosterone in the distal tubule triggers reabsorption of sodium and chloride. Sodium-potassium pumps force potassium into the tubule as sodium moves in the opposite direction. H+ ions are let out as bicarbonate ions return to regulate the pH of the blood. The final step of our journey is the collecting duct, where urea and NaCl are reabsorbed. This is where hydroregulation occurs. The hormone ADH combats dehydration using aquaporins, and dehydration can be minimized by keeping water in the filtrate.